welcome everybody, third Teacher International. So this is the third time Teacher International. So today's MC is Rao-san from Nagoya University. So please take over.
Thank you very much, Sawaka-san. Myself, Tupati Upendra, a third year doctoral student in Chemical Systems Engineering Department of Nagoya University. Thank you very much, all of you, for participating in this event. So today we would like to discuss about the startup situations in India. The last event was also about the startups in India. So we have Mr. Arun has basically given the introduction about India and then basic introduction on the startups. So we would like to continue that startup introduction in this event. So this map shows the unicorns across the globe in 2021. So we can see that India has already minted more than 81 unicorns in the year 2021. First of all, what is a unicorn basically? A unicorn is a startup which has the income of more than $1 billion US. So while India leads the world in terms of average funding raised by the unicorns, the country's need of the hour is to create a policy framework that supports the growth of the startup ecosystem organically. So, so this is a good opportunity to learn more insights from the people who actually in the startups. For today's topics, we have three guest speakers. Mr. Rajiv Saikia san, founder and managing director of IIT Guwahati-led startup RD Grow Green India PVT Private Limited. Dr. R. Sai Chandra Teja san, co-founder and chief operating officer of IIT Hyderabad-led startup PMU Semi Private Limited, and Mr. Mayur Shah, head of business development group in India at Bevine Next Ventures. Now I would like to request Mr. Rajiv Saikia san to give a brief introduction of himself and the startup.
Okay, can I share my screen?
Yes.
So,
Yeah, good morning and thank you so much, ma'am, for giving me this chance and talking about my venture and all. I am Rajiv Saikia. As you can see, my startup is RD Grow Green India Private Limited. We are basically initial days startup. I was incubated at IIT in December 2016. The Startup India policy was somewhere around January or February 2016. So during that days, the startup, though there was a policy, and since we are in Assam, so policy was not at all that much clear. Then also everything we had to do something for the society and all. I am basically, though I am from Assam, but I was stationed at Delhi, NCR, Faridabad for almost 28-30 years of time. But for the last 5 years, all because of my startup, I'm working alone in Assam. My family, my kids, my parents are at Delhi NCR only. So I was thinking to do something for the in the field of water in Assam, since we have got arsenic and fluoride here. So somehow I was connected to IIT Guwahati, and my journey started from there. So December 2016, I was incubated at IIT Guwahati, and since then, we came up with two products. I will just cut down it basically. In 2017 July, I was supported. I was the first person, Oil India Limited, a public sector unit, a government body, which was the first PSU to support the startup in India, and we were the first from the Northeast to get this support from there. So we basically gave them a solution of treating their drilling effluent, oil drilling effluent without any chemical. This was the basically the innovation which we did, and for this only they came up, they took an equity in the company, and again GAIL India Limited, the other public sector unit, also took the equity in the company. So as of now, IIT Guwahati, GAIL and OIL are the three major shareholders in the company, supporting us on my innovation. So we came up with two products. One was Shuddha Jal, which is for treating water contaminated with arsenic and fluoride without any chemical or any heavy metals. And the other one is this one. This is e-Filtex, which is to basically for gas, oil and gas exploration industry and other effluent. We do this without any chemical through electrocoagulation. We used to convert the AC current to the DC, and we used to give currents to the electrodes, be it aluminum or iron, as per our requirement. No chemical is used. As a startup, this was my first, e-Filtex was my first piloting, but as a startup at those days when oil was also not clear about the startup policy, we were also we asked them, sir, how much do you need a plant to basically treat your water? So they told us that we require a 5 meter cube, 5,000 liter per hour kind of plant, which basically caters our issues. So this was the first pilot plant, which was a huge pilot plant as a startup. If I talk about the dimensions of this, it's somewhere 14 feet length and 8 feet height and 8 feet width. It's a huge width. The bigger one is the main filtration part, and the portion, the smaller one, is the reactor, where we have placed our this what you say electrodes and all. We used to give the currents to this section and it goes to the other. So this was the first venture. We did it all because of this. As of now, I am basically able to speak to you all about my ventures and all. And we did almost 6
Sorry, Rajan, for interrupting. So we cannot see your sharing of your presentation. So it's
you're
just
not able to see nothing, no slides you have seen.
No, we can see the slides, but we cannot follow up the slides that you are talking of. So we can just see the introduction slide of like the first slide only.
Now?
Not moving.
No, not moving. So you can maybe put it in the full presentation mode.
Now?
Oh,
Yeah,
yes,
now
yes.
it is moving. So
Yes.
yeah.
Oh, I see. Okay. Apologies. So this
Sorry.
is the basically what I was talking about, 5,000 liter per hour plant for the oil drilling effluent. And this one is the smaller plant for fluoride removal kind of thing. The arsenic and fluoride part was supported by GAIL India Limited, and the oil was supported by this Oil India Limited. And all this has been done without any chemical through electrocoagulation. And if I talk about in the oil field, this is the kind of water which we used to get daily. This is almost 15 days water, and this water was treated like this without any chemical. This is the basically innovation which we did, and that's it. As of now, we are working for the Jal Jeevan mission in Assam only. It's a government project, and trying to basically give ideas and give to the basically students and all, how they have to come up with the ideas and how they can apply for this, how to pitch. This is what right now I am doing for the society and all. Thank you. Over to you.
Thank you very much, Rajesh. Like myself as a chemical engineering, I know how hard it is to treat hard water, and then knowing that you are treating this the water without any chemical is a great achievement. Thank you very much for your insightful and like a broad introduction. Now I would like to ask Dr. Sai Chandra Teja-san to give his a brief introduction about himself.
Thank you, T Chan and team. Thank you for the opportunity. I'll share some screen and broadly cover what we are working on. Is the screen visible?
Yes.
Hello. Yeah.
Yes.
Okay, so I'll broadly mention about my academic and professional journey. I did my bachelor's from JNTU College of Engineering, Pulvendan, Electronics and Communication stream. Then I did my master's at IIT Hyderabad in microelectronics and VLSI, and I pursued my PhD in Japan, Osaka University. And after Osaka University, I through job hunting, I worked at Toshiba, previously Toshiba, and then renamed to Kioxia at R&D Center, working on mobile memory, so SSD firmware and reliability. During COVID, to start my entrepreneurship journey, I returned back to India, and then I started 2 startups. One is Green PM Semi and CCAM Vision. Both are focusing on building Society 5.0 technologies. Just for the Japanese audience, it's watashi no namae wa Teja desu. Indo umare shekai din toshite Nihon sodarete nichin kanke ni yaku ni tatsu jinzai ni mezashite masu desu keredomo, watashi wa Indo umare desu keredomo shakai din toshite professional journey mo Nihon te hakase totte shinshotsu saiyou no watashi no kengyū kai center de shinshotsu saiyou te haitta node, そこで育てたかなと思ったので、日印関係に役に立つ人材になりたいかなと思ってて、私のスタートアップにも日印関係の愛知県のものづくりの、大企業大手メーカーとの連携を目指してますね。Then I'll briefly talk about Green PMU Semi. We are a fabless semiconductor company founded in 2021. We are based out at IIT Hyderabad at an incubator named Fabless Chip Design Incubator. We are a team with strong research expertise and product development experience working in analog ASIC designs, so predominantly in power management and energy harvesting. I broadly talk about what are the offerings of Green PMU Semi. So we have 2 lines. One is product line, which is energy harvesting IC and power management IC. The other one is a custom solution, which is custom ASIC and custom IPs. So why there are 2 lines? It's like for the cash flow perspective, we are looking at providing custom solutions, like demonstrating our expertise in analog low power designs. So what is our solution in a way? So we have a lot of ambient energy available. There's a lot of sensor devices which are used in everywhere, right? Let it be device, let it be industries, let it be buildings, everything is being connected and everything is demonstrated towards being a smart community, right? So what we are trying to do is we're trying to harvest ambient energy, which is in terms of solar, thermal, vibration, and our Wi-Fi signals available, and translate that into a usable voltage efficiently. So there are commercially available ICs available in the market, but they only do the harvesting from single source. So our differentiator is we have the ability to harvest the ambient energy from the multiple sources simultaneously, and then effectively kind of drive the battery source or recharge the battery or drive the sensor system. So in Japanese, it's predominantly kankyo hatsuden. Kankyo ni aru energy o battery no recharge ni skaeru denryoku ni henkan suru kiki no 半導体機器になってますね。それ我々のプロダクトがこうなってて、IC と同時に我々の、設計開発知識に基づいてカスタムソリューションズにも我々のオファリングになってます。So there are 2, so this is our solution and this is the advantage with respect to the commercially available big players like TI and Maxim. So our boosting efficiency and low input power is higher. And we have a multi-source harvester, which is predominantly not by any other company. We have another competitor like Zydus, but it's only harvesting energy from 2 sources. So the takeaway is we are trying to kind of contribute to SDG goals in a way to reduce the battery usage and use the ambient energy to drive the sensor devices. So for this idea, we have been selected for the Semiconductor Startup Incubation and Acceleration Program by NXP India, FabCI, MEITI, Ministry of Electronics and Telecommunications, Government of India, and Startup India. So that's predominantly a brief introduction. And yes, so one key sentence which I love is, reality can destroy the dream, and then why shouldn't the dream destroy the reality? In a way, so most of the students or any other employees who have a dream, which might not be realistic, but if we kind of try pushing those dreams, it will become the reality. Thank you. Over to you, Teja.
Thank you very much, Teja-san, for your quick and profound introduction about yourself. And like about your startup also, I also like to thank you for translating your for speaking in Japanese, explaining in Japanese for our Japanese audience. So we have really quite become acquainted with your startup. So now I would like to move on to Mayur-san. Quick introduction about yourself. Mayur-san, now over to you.
Am I audible?
Yes, you are audible.
Invisible?
Yes.
First of all, good afternoon, everyone. Thank you very much for taking time during your lunch time. I know it's in Japan, it's 12 to 1. And thank you very much for enthusiastic participation. We are really thankful for your time. Very quickly, this is a brief profile. So I have spent more than 25 years between India and Japan. Yokohama Ichidai de shushikate shitoku shita go. 最初の11年間ぐらいIT 業界に勤めておりまして、その後金融に移って、過去12年間、法銀のシンクタンク的な機能をずっと担っておりました。ちょうどそのコロナになってからなんですが、やっぱりインドスタートアップの到来と日系企業をつなげていくと、そういうテーマにとても興味あり、それで Beyond Next Ventures という日本のベンチャーキャピタルに入って、今インドの事業を主に見てます。So that was my brief introduction, quickly in Japanese. I think the English audience can read what I've written here, so I summarized it. Let me just go through quickly on what we do as a company, and then maybe leave a point of the relevance for the future discussion. So this fund was started by two very interesting founders. I mean Mr. Tsuyoshi Ito, in 2014 to solve a particular problem, a social and educational problem in Japan, to create high-end entrepreneurs from the tables of lab. And he had succeeded in taking some lab ideas to IPO. And the whole idea was to kind of have a fund that supports this kind of entrepreneurs. And first fund was around $55 million. Later on, we also raised the next fund at $165 million as well. We have a couple of frameworks that help achieve this dream, because whatever the ideas that come at the university levels that need a business acumen. So we have a very interesting acceleration program wherein we also deploy some of the existing veteran human resources that are working in Japanese industry. So they join in during the acceleration program, and some of them decide to even join as a co-founder later on. So we provide fund, we provide the managerial resources, and then we have access to quite a large number of Japanese corporates, because they also are very excited to look at these new ideas and research results that come out of it. So we also do the industry connect, and that's how we try to contribute to the ecosystem. And we have won quite a few awards even from the Japanese government. Our global portfolio, as of now, bulk of them, 80% are from Japan. Obviously, we are Japan-based fund, but there's a conscious decision to invest in India. So from our second fund, that is $165 million, we are spending 30 million plus, I mean 20% more plus to the Indian open innovation ecosystem. Just to give a context, around 200 to 250 crores kind of rupees in Indian context. Very quickly, what we do in India. So this is our sweet spot. We basically like to come at the seed and early and before pre-series A kind of a stage. Depends on the kind of a company. Around anywhere between 200K to 2 million is whatever suit size. In Japan, we are largely focused on the medical and the health tech side of it, but in India, we are a little wider in terms of IoT, agri-food, energy, and as you can see, all the other sectors as well. And this is my last slide. And why do we feel, and probably it's also relevant because there are many participants from Japan, the young people who are looking at it, or some of you are from the corporates. So our hypothesis is, when we look at the India-Japan collaboration, and since I wrote my thesis on Indo-Japan economic relations, and I have almost lived that life connecting Japan with India, so I've come to the conclusion that if you want to describe India for the next 20 to 30 years, India is going to be ideas, because we are at the very disruptive curve at this point. And Japan, if you want to describe in one word, I would say it's not manufacturing, but it's the scale, monozukuri at scale. Because it's not just like how do you manufacture one particular thing, but how do you plan from the slightest buhin, how do you get the inbuilt quality, how do you make sure that your consistent quality is maintained, and then you make it at a global scale. Now that is something Japan has it. India has a very interesting disruptive ideas which can kind of revolutionize quite a few industry. And very interesting analogy that I would like to use here. When I was a student and I was writing my thesis in Japanese, I used to read a lot about early stage entrepreneurs of Japan in the high economic growth period of Japan, early high economic growth period of Japan. There was something very common of those entrepreneurs then and current entrepreneur in India is that common man or the youth of the nation feels whenever they see any problem that it is their responsibility to solve this problem and not leave it to a large industry or government. And that phase in India, I feel is going to continue for next 20 to 30 years because of two reasons, or maybe multiple reasons, but primary two reasons. One is we have a huge demographics. So the younger productive population is going to continue. Second is the kind of access we have in terms of problem. One of the word used by Jugaad, I think Teja earlier, but so that will kind of make people innovate. Of course, there is a lot of government backing everywhere. And since, as in the earlier presentation, it was mentioned that already India is the third largest unicorn producer. So there are many funds that will come chasing India. And this is where we feel that Japan can play a major role because 70% of the Japanese companies in India are actually in the monozukuri side of it. So while India will be very good at idea, but beyond the conceptualization, beyond a certain market level, if it has to go global, there could be a very good collaboration there. And that's what we're starting. With this, I'll stop my presentation and look forward to interactions.
Thank you very much for your brief and enlightenment introduction, Mayur Shalsan, especially about India-Japan company investments across various sectors and fields, and especially about taking the responsibility at basic level, like wherever the problem occurs, like taking the responsibility of the at the basic level. It was so very insightful, and thank you very much for your introduction. So now I would like to move on to the panel discussion about this starting and then challenge that that were faced during the startups. So I would like to ask the panel members the first question. So, like, what kind of the ideas that were act on while you were starting a startup? So, what kind of ideas that you are considering, and then how you consider this idea is the best to start, to start the proceedings. I would like to, I'll ask the panel members to answer this question. So, Rajiv San, so yes.
Okay. I would like to answer because since long I was hearing there is a problem in Assam. It's a pain point. Arsenic and fluoride, the pain points. And my startup is a mixture of it's an umbrella for which has got civil, mechanical, chemical, every engineering in one roof basically. So the pain point which was there, and there was no treatment, and though there was innovations in this fluoride and arsenic, IIT Chennai has got nanotechnology, but they are all basically it's a chemical based technology, and we are now talking about the green technology without all these things. So one of my professor from IIT Guwahati, who is from the chemical engineering, my basically mentors are from the chemical engineering departments only. We have got two professors in my company. They are the whole-time directors also in the company, so they are helping me on this front for research and all. So the pain point was arsenic and fluoride. So we thought how to go about it. Then I approached IIT Guwahati, and we come up. They did something on synthetic water, but doing a getting a PhD degree or getting a patent on a synthetic water and getting it done in the field, it's totally flip. When you work on the reality, it's completely a different thing if you talk about a synthetic water and a water which is in the ground. So the challenges was tremendous. And since it's a northeastern part, though I was at Delhi NCR, getting supply chain was very easy, but in Northeast, it's toughest thing. The people don't know. I have got some idea, professor have got some idea how to make it into reality and all. The pain point was arsenic and fluoride, we know, but how to come up the solution and all. The solution was there in the books, the solution was there in the pen and paper and all. So we did a deep thorough study in the market. I used to come every month. I used to stay over here for 15 days, go to the ground, get the data and work again with the professors and all. It took so much of almost a year or so, or 9 to 10 months to work. So after this, you have to see the market also. Pain point is not there. You have to see the market also. And the water is basically given by, normally the drinking water has been given by only basically the government department, public health engineering department, all which is basically supplying the water and all. So telling to the government that we have come up with a new idea and treating this water, it's a difficult task for me. Today also, I used to face so much of problem to make people understand, say this is the way we used to do. Earlier you used to treat the water with chemical, we are without chemical. You used to keep the track of the chemicals, we don't have to track the chemicals. We are just placing the electrodes and we are giving current, and no need to track the how many kgs of this slime is coming or alum is coming or something like that. So basically pain point and the market study is very much required. Over to you. Over to you.
Son, treating water. Thank you very much, Rajiv San. Knowing that we can treat the water without any chemicals using electrodes is such a basic, a great achievement. As a chemical engineer, I also know about treating water. And removing arsenic and fluorides from the effluent water or general water, supply those water to the general public, and then getting the this startup idea to the government is itself is a big challenge. So thank you very much for your introduction, your explanation. I would there are questions from our audience.
Matsui-san and Nanzawa-san.
Matsui-san.
And Nanzawa-san, we can see that raise your hand. So if you have any comments, could you?
Yeah, hello, Teja. Yeah, I'm only listening, so no comment. Sorry, yeah.
Sorry.
Okay.
Nanzan.
That's what Nanzan-san.
Okay. Who is there? Is one more raising hand.
Matsui-san is also okay.
Matasu-san.
I think that's okay.
That's fine. So now I would like to ask Sai Chandra-san about this same question. So how you faced your challenges and what were your basic ideas on starting your startup?
Oh, Teja-san froze.
Teja-san?
Freeze. No?
Froze.
Froze.
Teja-san, can you hear us?
No. So maybe go to the Shah question to the Shah-san.
Shah-san, we would like to ask you about what are the key factors that a company basically considers supporting a startup in India?
Yeah, thank you very much. I mean, I think as I was saying in my presentation, let me show one slide that might kind of make things a little clearer. Just one second. And since we focus on the Japanese corporates in India, We have close to 1,400. So when I look at the issues faced by Japanese companies in India, and then I look at the Indian open ecosystem, where do I see the challenges and the opportunities? Of course, there has been consistent growth about the number of companies from Japan in India, but the numbers are still very low compared to the potential that both companies have. One of the reasons is that Indian market has evolved very differently from all the other market that Japan has got some reference point to. So there is Shori no Hoteshki, winning formula is missing as far as India is concerned. The second point is again the strong human resource network that companies should have internally to manage the affair. That quite a time a bit lacks kind of stuff. And the profitability takes little longer time in India compared to other countries. Now, these are the major issues that Japanese companies face. Now, this is in the context of the old economy. This is how India used to be, and this has been a consistent issue. Now, if you look at it since what's happening since last at least 7 or 8 years, with lots of startups coming in, starting with the fintech to even the clean tech, or for that matter, even the telemedicine and all, the disruption is taking place at a breakneck speed. We do not have many resources. The innovation becomes key for the solutions whenever anybody thinks of it. And this disruptive business model is a great chance. And as I was saying earlier, it's a throwback to Japanese early high economic growth period as well. Also, Japan has the largest reserves in terms of, the savings and all. And the third and important point is that India has a huge population. So any solution that is born out of disruption, if it reaches an economies of scale, then it has a great chance to even take it global. So this is the reason for any corporates to look at India and see what business they are in, the way Indians are communicating with the brand, the way the companies are communicating with supply chain, the companies are communicate with other company. The models are changing and evolving every day. And this is where Japanese companies can also have a closer look and take advantage of this huge new force to reckon with called Indian Open Ecosystem. Thank you.
Sorry. Thank you very much for your explanation about this topic. So is Teja-san?
Yes.
Hello?
I'm so sorry for the technical glitch.
Uh,
So I'll briefly, I'll keep my video off and then briefly talk about the idea, right?
yes.
So I think some of the people are aware of a concept named Society 5.0, which was introduced in the 5th Science and Technology Basic Plan by Japanese government. So the Society 5.0 says it's a human-centered society that achieves both economic development and resolve the social issues through integrating cyberspace and physical space. So nowadays there's a huge, transformation in manufacturing happening through IoT and artificial intelligence technologies. But Japan focuses to use these technologies to resolve the social issues and also achieve the economic development. So that was a kickstart point where I was thinking that there are a lot of technologies which are being developed, but the thought process of actually contributing to the future generations or the future societies, or actually developing a society where you resolve the social issues and also achieve economic development was a starting point, right? And then I searched a lot about Society 5.0, trying to understand the motivation behind it. If you just to give a background, right? So everybody must have thought about Industry 4.0, which says a digital transformation of manufacturing in itself. So it is predominantly just to transform the manufacture, automate it more, and then help contribute building products, which will help, into transform the lives of individuals or the social life of the individuals. But if you're aware of the Sustainable Development Goals established by UN, some of the key problems are from the social perspective, right? Are from the social issues across the world. So in that sense, this Society 5.0 technologies or utilizing technologies to answer that was something which is a study point. So that is why I ventured into AI and IoT fields. So Green PM Semi focuses on utilizing the ambient energy. So ambient energy, solar light is available abundantly depending on where you are in the world. Let's say if you are in Japan or Russia, you have a lot of cold during winters, right? So that is also some kind of an energy which is available. So why can't we harvest that ambient energy and then contribute into any field, right? For me, I'm an electronic field semiconductor expert. So I was thinking, how can we take ambient energy and translate it to kind of transform the electronics in a way? It's a simple use of energy and conversion of that into a usable voltage. So that is what Green PM Semi is focusing on. We want to utilize and transform the energy and then shift it into a usable voltage, which can be used to drive the battery, drive the sensor device, and make it autonomous. So that is a key point. And then and Rajiv sir has mentioned and Mayusha sir has mentioned, right? So it's like, okay, that is the idea I have. But now I have to understand what the product market fit is. Like there is something called a PMF. One thing entrepreneurs like is, once you like an idea, you involve so much into the idea, but there has to be technological relevance, a product relevance, and a market relevance, which will come into the play. So that is what we are trying to solve and trying to understand from the ground, how with technology, we can contribute to the SDG goals and also utilize the ambient energy available around us. Thank you.
Thank you very much, Teja-san, for explaining about the Society 4.0, which is basically conceptualized on digitalization, and 5.0 on sustainable development, and then the basic ideas that were proceeded by you. So I would like to ask from the audience if they have any questions on regarding this particular panel discussion about like starting a startup. So basic ideas. So you can ask the panel members and they are ready to answer your questions. Any audience, any question from the audience?
Hi, can you hear me?
Yes, we can hear you.
Thank you for organizing the seminar. My name is Karthik, and my question is for Teja-san. So thank you so much, Teja-san, for for introducing the work that your firm is doing. To use ambient energy more efficiently is certainly quite interesting. Could you share a couple of potential examples of where this technology you're working on could make a significant difference from existing use cases for semiconductors? And secondly, from sort of like you talked about product market fit, right? Maybe one of the important factors over there is about pricing. So this new technology, if it, I believe it might reduce the prices of some of the semiconductor goods because they don't need to have any external electricity connection, etc. So would be great if you can share also a little bit about what you think regarding the impact of pricing on based on the technology you're developing. Thank you.
Thank you, Karthik. Can I take the question?
Yes. It's the question is directed towards you only.
Yes.
Yes, huh?
Yes. So I'll give you two examples. So one is we have office spaces, right? So these are office spaces where in every room there is a temperature sensor, pressure sensor, and a monitoring sensor system which is involved in the room, which is connected through the wiring. So if you take a 10-story building, so most of the floor there is a temperature sensor, pressure sensor, CO2 sensors. If it's a laboratory, there are extra sensing elements which are taken into the pictures, and there is a lot of wiring which is involved. All these sensors are driven by battery. So what happens is once this battery is depleted during the weekend, a human resource will come in. He will manually take out the depleted battery and replace it with a new battery. So what is happening is, let's say your battery lifetime is for 3 months. In an year, I need to kind of do this 4 times. So for the entire building of 10 floors, I need to assign some resources, get the batteries, replace it, check the wirings, whether the sensor is working correctly or not. And then this is a conventional process which is happening, right? So now when I'm saying how do we effectively utilize ambient energy, to give you a brief background, there has been a huge innovation in materials which has happened. So previously, only the outdoor solar cells, right? Outdoor solar panels to harvest, like if you can keep many solar panels in series, then you will be able to harvest energy which could be usable. But now with rampant innovation in material sciences, they are able to kind of harvest energy from indoor light conditions also. So from tube light illuminance, I am able to harvest energy. So now with this innovation happening, that is where we want to step in, right? So now what I'm saying is now your same 10-story building with a lot of sensors, lot of wiring, and with manual intervention of 4 times a year, I'm trying to introduce energy harvesting, which is an external component onto the chip, where now I'm able to harvest the energy from the indoor light only. So in the office, the light is always on predominantly at all the spaces. Then with that available energy, what I'm saying is now you can remove the wiring, because this energy will be able to drive the sensor system. Of course, there are ambient light energy available. If it is in a lab where there are some machinery which is continuously running, there is a temperature difference. You can use also to the thermal electronic generator. If the machines vibrate a lot, then you can harvest that vibration available. So whatever energy is available, we are trying to harvest it and then utilize that to drive the sensor. Now even with this conventional wiring, the temperature is being sent, like monitored once an hour, and then that is kind of stored somewhere. With these intermittent systems, now I'm saying is I will remove the wiring, I will reduce the battery timing change, because wherever they have ambient energy, now you're changing it 4 times a year, but maybe with this energy harvesting, it will be cut down to one time a year, because the material transducers have a lifetime of 4 to 5 years. So when we compare these two, now your second question of pricing will also come, right? Now in a year, when my maintenance is happening 4 times, I need to buy more batteries. That is contributing to more electronic waste. That again is contributing to sustainable development goals, more carbon footprint. Now what I'm doing is I have the same battery. I'm utilizing the ambient energy, available energy in that space to extend the battery life and then do the same function which it was doing before. But more effectively, it is little intermittent. That is the first thing. And when you asked about the product market fit with respect to the costing, so one is this secondary costing, which is coming into the place, where like human resource cost, the downtime, intervention, maintenance costing. When we consider the semiconductor system in itself, there are a lot of discrete components which come in while building an embedded system, like a sensor system, right? So it has an MCU, it has this microcontroller unit, the microprocessor, the power management, some kind of a sensing devices to effectively rail the battery voltage. By utilizing this energy harvesting, actually you get a regulated voltage, because it's an intermittent ambient energy available, and then I regulate it and send it. It's actually more efficient than driving it with more power lines through battery. This is more technical in a way, but I'm just saying, how do we reduce the cost, right? So the different discrete components will be replaced by the advantage of a regulated supply from this energy harvested chip that can be utilized to recharge the battery. So that is where our USP lies in. Selling point would be you reduce the cost primarily on the system by reducing the discrete components and effectively giving a regulated supply. That is a need of a sensor system. And secondarily with all this, right? Okay, the maintenance cost, the human resource cost, extra batteries cost, that is again reduced by utilizing the system.
Thank you very much for your explanation, Teja-san. I think Karthik-san, like you have got the quite good explanation about your question. Now I would like to ask Japanese students, even they can ask the question in Japanese also. So are there any Japanese audience who can ask the question?
No.
Teja-san, I have got one question for you. So who are the target consumers for your products? Like how long it will take to reach the general public for your product to reach general public?
Yes. Hello. Am I audible?
Yes, we can hear you, Teja-san.
Yes, I'm back. So what I'm saying is the target audience are any sensor system, right? So starting with wearables, where you are saying all the variables now they are saying, you know, once you have a watch, depending on the temperature difference across the ambient and your body, you will be able to harvest. And the fitness trackers, where you run with the vibrations, your battery life will be extended. So this is where one of predominant application very close to you would be the wearable devices, which is the consumer IoT space, right? So consumer spaces where it's small sensor devices like wearables. When you go to an industrial space, like the smart buildings or office spaces, which I gave an example, and industrial manufacturing plants, there are a lot of sensors installed in a manufacturing plant with respect to the quality process, right? So there has to be a very less defects or in a way. So vibrations from the machine, I use that vibrations from the machine to kind of prognotively, like as a prognosis for the maintenance. So these sensor devices, wherever they are installed, through ambient energy available, I'm extending the lifetime of the system. So two biggest market segments are the consumers, where it is predominantly you see in day-to-day life, right? The wearables where you watch. In medical, it's a wearable ECG patches where they use for condition monitoring. With COVID, it has been very prevalent in a way to kind of do the remote monitoring of the patients. So they have given all of the sensor devices to the patients itself. So now in medical, it becomes very critical, because once the battery life is depleted, you can't monitor the patient. So that is where these energy sources or external energy sources or secondary energy source is very prevalent. So battery has been a keyword across the segments, right? If you see, everything is kind of, they want to kind of decentralized into a battery. Now if phone is your integral part of your life, phone battery is also an integral part of your life to do your payments, or everything is related to that battery space. So that is where we want to focus, where we want to kind of harvest energy available around us and then be as a secondary source, not disturbing the primary source line. So it is wearables, it is ECG patches, condition monitoring, industrials, basic sensor devices, and any defense applications like if you want to monitor a dam, you can't install any sensors, or not like a building. I can't send a person to where a sensor is deployed in the water to kind of change the battery every four times in a year, right? So when you want to sense data from environments which is physically not accessible, or it is difficult to access physically, like if you want, in Japan, the most relevant example is a nuclear plant, right? Now everybody want to understand the situation across the Fukushima, but they can't send a human because they will be found to radiation. In that spaces where we can send the sensor. Now, if you send the sensor, when the battery is depleted, you need to again call back and change the battery. Now, if I have energy harvesting available, let's say there is temperatures difference available, solar light available in Fukushima, I can send my sensor, which can work intermittently, harvesting the solar energy. Then my sensor data can be utilized. So this is predominant example where humans can't reach, or where humans will be affected, and then you want to sense the data. This is more prevalent there.
Okay, I have one more question, sorry. So your products are basically the second sources for the energy, which are totally based on the primary energy sources, right? So doesn't it take long time to produce the energy? Basically, it is like if you say atmospheric solar light or any other energy sources, but it does take long time to accumulate the energy, right? So in that case, like how it is going to be sustainable product? Perfect.
It's a really nice question, right? So when I mentioned about a sensor system, so not every sensor system are a duty cycle systems. Okay. If you understand, if I'm monitoring a temperature of the room, I'm not doing it every second. They're already duty cycled, because if it is not duty cycled, your battery will not last. Nowadays, your battery will last for months, because it is a duty cycle system where I'm monitoring the temperature depending on the history, right? If the experiments are conducted in the afternoon, where predominantly fire accidents can happen, people do that in afternoon. Maybe they'll take 3 data points, but across the day, they might take only 1 or 2 data points. So this is a duty cycle system in itself. Before only it is a duty cycle system. Yes. Now in this duty cycle system, my primary source is now only battery. If you look at it. Now when I'm saying keep predominantly harvesting energy, if my solar energy to harvest, as you rightly mentioned, I need to capture the energy, then I need to store that energy, and at some point of time, effectively convert it into change and recharge the battery. My system is already duty cycled. So within that 1 hour, I'm able to harvest the energy. And if I'm not able to totally convert it, within the next hour, I'll be able to convert it and make it usable for the battery. So in a way, the system development is already a duty cycle, which makes it much, much easier for us. These things will take time. The system already is giving me an opportunity to utilize the time in between the sensing data to use for it effectively.
Thank you very much for your explanation. Yeah, it's basically like consecutive backup to the primary source.
Yes.
So now I would like to ask the second question about what kind of challenges that were faced during the initial days. Rajiv-san, I would like to ask about this particular question, because you have mentioned several PSUs like GAIL and Oil, which were collaborated in this water treatment. So what kind of challenges that you were faced when you want to introduce your idea to these PSUs? So how they responded, and then what were the suggestions they were given to you? Like what were the requirements they asked you? So could you please explain about this situation?
Okay, thank you. Nice question. Basically, I was fortunate enough, I was so lucky. What I told to the PSUs or the government body, they accepted everything. I was half sold when I was incubated at IIT Guwahati.
Okay.
I passed the 50% marks I cleared when I was incubated at IIT Guwahati. I was able to convince the IIT professors. Then the logo which I had with me with my company with RD Grow, I had IIT Guwahati. I was half sold. So what I told to the PSUs, they asked me, then where is the glitch, when we can start? So I was so lucky on that front. Really, I'm telling you, this is not I'm not joking. This is what people should say. If students or a startup who are incubated at somewhere, they should know where they are giving their equity, where they are basically selling themselves, how they are selling themselves. So for me, I was into the stock market. So I know the value of the money and how to convince people, because in the stock market, it's only the face value, or somewhere down the line, you don't see the face also. So convincing to the people is more than nowadays. I was thinking, I've just noted down, I will try talk to Shah-san also, because right now I am basically into the startup ecosystem, making an uplift of this startup ecosystem in Northeast. When I come up, I'm just debating from my startup. Basically, what I have seen during these days, I have visited n number of colleges and all. Students or the startups, they don't know how to pitch. What are the points they have to cup up in 2 minutes of time or in 5 minutes of time? Where they have to bang the hammer? They should know. So this is what I am trying to do all this time. And for me, basically, incubation as of now is incubation, hand holding and monitoring, market connect. And in basically incubation, you should have the prototype fabrication unit also. Mine is basically hardcore engineering. Yes. So I need a space. So these are the things, basically hand holding, mentoring for the market, and the market connect. Market connect is basically a very useful thing or very important thing, all these things. And this is how basically, and when you come up with the challenges on as a startup, you know how to tackle with all these things.
Thank you very much, Rajesh sir. So
More than happy to
if you
connect.
have a sorry, Shah-san, you are saying something.
More than happy to connect, Rajesh sir. Thank you.
So basically, if you have a sustainable idea, and then if you have good idea, startup ideas, the companies are very much ready to invest in your ideas. Yeah, thank you very much for your explanation. Next, I would like to ask Shah-san, just your quick thoughts on like what motivates entrepreneurs. So we don't have much time. So
Yeah, I think, it's very evident from both Rajiv San's talk and Teja San's talk. First of all, there is a conviction. We don't have to look for any other example. And as I was saying, that this is a phase that very resembles the past history of Japan as well. That both of them have decided that it's only me. I will solve this. And I have to solve this. And that makes them sleepless. That kind of drives them, wherever they go, probably even if they're meeting their friends or family or marriage function or any willing ear, they'll be only talking about this. And that is, as we say, kind of a passion or junoon or, muchuni naru in Japanese. That is what is the first and most fundamental thing that probably, a founder needs. And I think that drives everything. See, as Rajiv San said, it was his conviction that Guwahati was sold. And on top of it, PSUs asked him, saying, okay, fine, you don't need to tell me anything more. I think we believe in what you're saying. Or for that matter, what Teja is trying to do here. This is something very revolutionary. Look, it helps us, a country like India, because energy is extremely expensive for us. But then it also helps countries with a lesser population because you don't have people to maintain things. So the idea is amazing. And that's what probably, makes Indian open innovation so exciting. And maybe today's audience also, I would love even my Japanese friends to probably keep an eye on India. Because India is a gold mine of problems. And fundamentally, yes, you to create idea and then go for the venture capital to kind of, fund them. Yeah, that I'll stop.
That's a very, very good praise, like putting gold mine of problems. So now I would like to ask each panel members to quickly explain about their future objectives, like in one or two sentences, or like on what objectives you are focused on. Starting with Teja-san, what are your future objectives? Like how you want to globalize your startup?
Yes, so Mayur-san has mentioned about gold mine of problems, but if you have a solution for India, that will be relevant to the world. So once you have solved, or India has accepted, or it is a market fit for India, that will be kind of relevant for across the world, right?
Yeah,
being in a semiconductor field, you must be aware of the supply chain issues, which is creating global political and socio-economical factors also. So with that, startups are really struggling to scale. It's when I talk about, sir has mentioned about actually the scale thing, where Japan has a very total entire strength because they have domestic supply chains entirely fixed apart from the world. So world might be wondering or struggling for things, but Japan is self-sufficient in a way. They have a very strong supply chain in place, especially in electronics and supply chain manufacturing. So that is where we would request, countries like Japan or Germany, where they could kind of support scaling up ideas or startups predominantly from India and across the world, which are relevant at least to the contribution for the next generations. So that is one thing which going global will help us, because our idea, when combined with the system people, where the large corporation, the supply chain, which will come into place, we can reach to the more audience with a much bigger platform to demonstrate, the contribution of this idea to the transforming the lives of individuals, to transform the lives of or making it easier for the industries to monitor with lesser maintenance and stuff. So that is one thing which we would, as an appeal from a startup founder and across to all the startups for the semiconductor in itself, is a struggle for the supply chain, where we would request all the, large corporations to help, like lend a hand to kind of not resolve it, but at least support most of the startups. Where Mayur sir can play a lead role, at least to connect all the major industries.
Thank you very much, Teja-san. So I would like to ask Rajiv-san about your future objectives. Quick, like we don't have enough time, so in quick one or two sentences.
See, I'm more focused for the northeastern part only, because first I have to solve the problems for arsenic and fluoride over here. Then I will be in a month or so time, I will be visiting Bangladesh. Bangladesh has got the same problem which we have in this. As of now, this is only my idea. It's a span of almost 45 to 60 days time I will be traveling to Bangladesh. and mainly focused for my this domain over here only as of now.
Oh, thank you very much for your support. Yeah, and my
Just one sentence. I mean, it's a learning journey for us.
yes.
Going forward, would also like to see some very young and bright ideas from Japan and look India as a market, and that will be a good start for even the new collaboration as well. That's it from my end. Thank you.
Thank you very much for your explanation.
Thank you.
Thank you. So now I would like to hand over the session to Sawako-san.
Thank you very much for the participating, and thank you very much for the panelists for the nice discussion today. And then for the next Teacher International, 4th is we go to France. So please register and listen for the next session also. Thank you very much, everybody.
The next session, please share the screen.
That's okay.
Oh, it's okay.
Please
Okay.
check the website.
Thank you.
Thank you very
We
much.
thank
you
the
so much, sir.
participating in this event.
Thank
Thank you very
you.
much. We especially thank the panel members, Mr. Raju san and Teja san, and then Mayur san. Thank you very much
Thank
for your
you.
insightful ideas and then explanation about your startups. Thank you very much for joining us today.
Thank
We're
you.
gonna close.
Thank you so much.
Thank you.
Thank you.
Have a good day.
Have
Thank
a
you.
good day.
Bye.
Bye.